As we move on here with returning a pointer from a function, remember again that the notation that we are using here is the asterisk. So up here, we are declaring, I should mention this. I feel like I should mention this because it's been a while since we've seen it. We have the C standard library here and C time here, so that we have a seed and random that we can use in the example down here. I know that's been a while, and essentially what I can tell you is if you just have these two includes, and then down here we've got our srand with time, and there's our random assignment that we can do. That's how you can use random numbers again. So take a look and be refreshed, I suppose. So here we go. We are making our declaration, and this is going to be used to point to an array of integers called numbers. Here again, so remember, this is the big change we are seeing from previous chapters to here. What we're saying is numbers, which is a pointer. It is pointing to an array, and we seed that array with random numbers here by getRandomNumbers. So this is quite different, really, than how we've been using arrays in the past, because what we're trying to do with, well, what we were trying to do, let's be more clear. What we were trying to do was essentially access the arrays by using the element subscript. Here, we don't even need to worry about that. As long as we know that we're using pointers and we can point to the address from the array that we're looking for, think of how much smaller that's going to be than, strings or whatever else, because that address is going to return with a very, very small number. So we're getting the benefit of, a very slight improvement in the overall efficiency of, these 50 lines of code. So we'll walk through what happens here. Is we are saying that numbers, which remember is a pointer, equals getRandomNumbers, and 5. That's how many we are looking to seed it with. So here you'll notice that we are returning something. That's the only reason that this works, is this integer pointer has to point to an address, and this is going to return that address for us. So here we'll look at what's happening inside of getRandomNumbers. We are declaring a new null pointer, so a new initialized, essentially, pointer that points to null, which, remember, doesn't go anywhere. So this is the very same thing as initializing a value, or a variable rather, with the value 0. Here we're just doing good code that if you pass us a 0, we'll return you a 0. That's essentially what this little bit is, and I always feel like we should probably model good code once in a while. So there it is. Here we go. Here is our dynamically allocated array. So again, here inside of main, we did not create an array. This is the big wrinkle that we're working with here, is we are creating a new integer array called numbers here inside of getRandomNumbers. And the way we're going to access that new integer array called num is by its pointer here. So what happens is this the right hand side of this operation is completed first. New int num goes and creates a piece of reallocatable but survivable RAM. It does not die when this function goes out of scope because of that new keyword. And then once C++ has gone and created that space, we will assign to ARR for array, or maybe it's pirates. We will assign to ARR just the pointer that points to the first element here in num. So then what we do is we go through and we create our random number, and we use it to create the values that we're going to store in the subscript of that array, and we're using count again. So this one, just as a piece of mercy, uses the array element subscript again, so that we can just get this idea of new and delete out of the way, and returning a pointer out of the way, and then we'll start using its reference instead in our subsequent examples. I came back through and changed it. I had it change a heart in between video 1 and video 2 here. And once we've gone and we've populated our arrays, boom, we'll return array, which remember is a pointer here to there it is, our new integer array called num. And then here we can display the numbers with a simple for loop, because we have a pointer to the first element in that array. So we can again use the subscript count here, count, right? The subscript and then it's count, and actually display what our values are. So here we go. These are our random numbers, and that is them displayed here in the output window. Now again, we can free the memory here with the delete keyword, and I'm shrugging just a little bit here at, is it of drastic importance for you to do this for our developments? Not all the time. I will let you know with actual points values for new and delete when you have to do it much later on down the road, when we have some, bigger project developments. But for the time being, know that you can do this. Know that when you are working with big data sets, it is, as a matter of fact, an advantage for you to be able to do this. But again, within the scope of the 50 lines of code that we've got here, it's really an academic exercise more than one in fine-tuning, I guess, of how the code will run.